Okay, so lastly, we've reached the general gas questions. First up, which statement correctly describes what happens to particles and pressure as you increase the volume? So volume is increasing. What is happening to my pressure? And what is happening to particles? Right off the bat, I can tell you that the relationship between pressure and volume is inversely proportional. Proportional, blah, almost got it. So what that means is that as volume increases, my pressure is going to do the opposite. It's going to decrease. And as my volume decreases, my pressure is going to do the opposite and it's going to increase. So I can right off the bat go in and see if I can erase any of the answers because I know this relationship. So if I increase the volume, my pressure has to decrease. So I have to pick the one that says decrease in pressure. So not this one and not this one. I can immediately get rid of those. All right, I think that was the hard part because the rest is just describing my particles. So if you increase the volume, it means that you have more and more space for your particles to move around. So you have more space. Because you have more space, there is going to be less collision, so less crashing of your molecules because they have more space to move around. So the only answer choice that has that available is C. If you increase the volume, your particles don't have less space. That doesn't make sense. They have more room to move around. They don't have less space. So your answer is D. Next one, fill out the table. You are figuring out if solids, liquids, or gases are compressible or not compressible. Again, compressible is the ability to grab something and squish it together and make it really, really flat. So, solids, look at how tightly those particles are packed. It is probably not very compressible because it's already compressed. It's already really, really tight. So I'm going to say that solids are not compressible. Liquids, on the other hand, have a little more space in between their molecules. You could definitely squish these together. So these are definitely compressible. Gases have even more space between those particles. So you could definitely squish them together. They are compressible. Next one is rank the following in order of decreasing compressibility. That means from most compressible to least compressible. So I already know, based on this chart, that solids are least compressible because they're already tightly together. They are not really compressible. They're the least compressible. So I'm going to say on my little spectrum that I drew here that my least compressible are solids. And I know that my most compressible are the ones that have the more ability to be squished together, and that are those are gases. They have a lot of space between the particles, a lot of room to be compressed. So that just leaves liquids in the middle. Liquids are compressible, not as much as gases, but more than solids for sure. And that all is based on the amount of distance between the particles. Last question of the review. Which flask has the slowest average kinetic energy? Remember, average kinetic energy is just movement, how fast they move or how slow they move. And this is directly affected by temperature. Remember in all of those explorers where if you increase the temperature, the particles went super crazy, but if you decrease it, they like slow down. So the slower the average kinetic energy is because the temperature is probably cooler. So you have to look at these temperatures and pick the lowest one. The one that has the slowest moving particles is going to be the coldest one. And that is flask 1 at 273.